Okay, so hello everybody. So this is quiz 8 we just took. So I'm going to go through the solutions here. So just to clear up any confusions here. So the first one that we see, we have, we want to write the power series representation centered at 0 for this function right here. So the first step we'll want to do is, let's use some properties of logs here, and I can rewrite this as natural log for 1 minus x squared over 2. Okay, so I've changed the root into an exponent, which I can bring out in front, and then I factor out a 4. Now the next step I could do here is rewrite this as natural log of 4, natural log 1 minus x squared over 2. Okay, so now we have two natural logs. This is a constant, so I don't have to worry about this for now. This one right here, I am going to keep in mind that this power series over k, for k going from 1 to infinity, and that converges from -1 to 1. Okay? Alright, so then doing that, I can rewrite here this x squared over 2. Okay, so I'll just rewrite it so that I can use here this power series representation, where x in our case is going to be x squared over 2. All right, so minus to the k. Okay, so now we have a power series here. Now let me clean this up a little bit. So we'll have x to the 2k over 4 to the k times k. All right, so I just redistributed the 1/2, and again, 1/2 natural log of 4 is just natural log square root of 4, which is where that came from. Okay, so we found the power series representation. Now we need to find the interval of convergence. Okay, so I'll use the ratio test here. So the ratio test tells me the limit k goes to infinity of the next term over the previous term. So doing that, we should get x to the 2k plus 1 over 4 to the k plus 1 times k plus 1. So that's the next term, the previous term, x to the 2k. Okay. All right, and then simplifying here, we'll get x squared over 4k over k plus 1. Okay, if we simplify this around, we'll be left with this. And again, this here is going to go to 1. They're the same power as we go to infinity. So we're left with this statement here. Okay, and this has to be less than 1. Okay, so a couple notes here. I think we were all a little confused as to how to deal with this thing right here, as was I. I think so this is what we do. So we multiply by 4 here. Okay, and then we take the square root at this point. So then we get the absolute value of x has to be less than 2, which means that x has to be between 2 and -2. Okay, and then we still have to test the endpoints. So for the endpoints, we'll see that we'll get for x equals to -2. Okay, so we see here, this is -2, and I can square it, so it'll give me 4. Which is our harmonic series, which I know is divergent. Okay, and if I do the same thing with 2, we'll see we'll get a similar result. Well, we'll get 2 to the k, 4 to the k, and I can square that 2, and we'll get, right, which is again a harmonic series, and it is divergent. So which means that our interval convergence does not include the endpoints here. Okay, so that covers number 1 here. All right, so now let's take a look at the second one. The second one, we have we have this, and we would like to come up with a function, the function that represents this power series. So if I rearrange the exponents here so that it looks like this, and this looks similar to this power series, which is again our geometric series, which is represented as 1 over 1 minus x. Okay, so if we do that, following that procedure here, this is going to be equal to 1 minus e to the negative x. All right, so that represents our function. To determine the interval of convergence, I use the root test, and that tells me the limit as k goes out to infinity is the kth root of e to the negative x to the k. All right, of our power series term right here, which is equal to e to the negative x, and for convergence, it must be less than -1, and I can rewrite this as e to the x must be greater than 1, taking the natural log of both sides. We get x must be greater than 0. All right, which tells me that my interval must be from 0 to infinity, and plugging in 0, we'll see that that is not included into our interval. We put in 0 into our power series, so we get 1 to the k. So it's just a series where 1, 1, 1. Which we know is divergent. All right, so those are the solutions to our quiz.